Welcome to the unit on algebraic methods, the factor theorem. The objectives for this session are to state the factor theorem and apply it to various applications. The factor theorem states that if f of x is a polynomial, then if f of p equals 0, then x minus p is a factor of f of x. And if x minus p is a factor of f of x, then f of p equals 0. Let's see how we can apply the factor theorem practically. So if g of x is a cubic, we can factorize it as follows. Substitute the values into the function until you find a value of p such that g of p equals 0. Divide the function by x minus p. The remainder is equal to 0. Then write g of x equals x minus p times a quadratic. And finally factorize the quadratic factor to write g of x as a product of three linear factors. Now let's have a go at an exercise. Show that x minus 5 is a factor of x cubed minus 7x squared plus 7x plus 15 using algebraic division and the factor theorem. Pause the video and have a go. Press play when you're ready to view the solutions. So let's use algebraic division first. Begin by dividing the first term of the polynomial by x, so that x cubed divided by x equals x squared. And position the x squared here. Then multiply the x squared by x minus 5. To give x cubed minus 5x squared. Now subtract x cubed minus 5x squared from x cubed minus 7x squared. To give minus 2x squared. Bring the 7x down and position it here. Then repeat the method. Divide minus 2x squared by x, so that minus 2x squared divided by x equals minus 2x. And position the minus 2x as shown. Now multiply x minus 5 by minus 2x to give minus 2x squared plus 10x. Now subtract minus 2x squared plus 10x from minus 2x squared plus 7x. As shown. Bring the 15 down and position it here. Now repeat the method. Divide minus 3x by x to give minus 3 and position it as shown. And then multiply x minus 5 by minus 3. To give minus 3x plus 15. And finally, when we subtract minus 3x plus 15 from minus 3x plus 15, we obtain 0. As there are no more numbers left to copy, we've finished. And therefore, x minus 5 times x squared minus 2x minus 3 is equal to x cubed minus 7x squared plus 7x plus 15. And so we've completed part A. Now let's have a go at part B. Let's have a quick recall of the factor theorem. Pause the video and read the steps on the screen, which we saw earlier. So let's solve this. Let f of x equal x cubed minus 7x squared plus 7x plus 15. We're going to substitute x equals 5 in f of x. Five cubed minus 7 times 5 squared plus 7 times 5 plus 15. And tidying up, 125 minus 175 plus 35 plus 15 is equal to 0. And therefore, from the factor theorem, we can deduce that x minus 5 is a factor of the polynomial. Now let's have a go at another exercise. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We are required to fully factorize the polynomial shown on your screen. Let's use the factor theorem. Begin by letting f of x equal the polynomial. Next, consider the minus 6 at the very end of this function. Now, we're going to consider all the factors of minus 6 and input these into the polynomial. So substitute x equals 1, x equals minus 1, 2, minus 2, 3, and minus 3 in f of x. Substituting x equals 1 gives us that f of 1 does not equal 0. Substituting x equals minus 1 again gives us that f of minus 1 does not equal 0. Similarly, substituting x equals 2 gives us that f of 2 does not equal 0. However, when x equals minus 2, we have that f of minus 2 equals 0. What about x equals 3? F of 3 does not equal 0. And x equals minus 3, we have that f of minus 3 does equal 0. And therefore we can conclude that x minus minus 2 and x minus minus 3 are both factors of f of x. As shown. And therefore f of x equals ax plus b multiplied by x plus 2 times x plus 3. In order to fully factorize, we need to find the values of a and b. In order to find the coefficient of x cubed in f of x, we have to multiply as shown. So we need to multiply ax times x times x, which equals ax cubed. However, f of x is equal to 2x cubed plus 9x squared plus 7x minus 6, and therefore we can conclude that a is equal to 2. Now, we also know that when we multiply all the constants together in these factors, in other words b times 2 times 3, we obtain 6b, but we also know that the constant term is equal to minus 6, as shown. Therefore, we can conclude that 6b equals minus 6, and therefore b is equal to minus 1. So we have now fully factorized f of x as 2x minus 1 times x plus 2 times x plus 3, as shown. Now let's have a go at another exercise. Sketch the graph of the polynomial shown on your screen. So let's solve this. Notice that this polynomial is the same polynomial which was fully factorised in exercise 2. Therefore, from the solution to exercise 2, we have that f of x is equal to the factorised version as shown. So when f of x equals 0, we have that this factorised version of our polynomial is also 0. And therefore, the curve cuts the x-axis at a half, 0, that is when x equals a half, at minus 2, 0, i.e. when x equals minus 2, and at x equals minus 3. In order to sketch the curve, we need to know where the curve cuts the y-axis, in other words, when x equals 0. So when x equals 0, what is the value of y? So when x equals 0, y is equal to minus 1 times 2 times 3. We can find this by putting x equals 0 into the polynomial to give us minus 6. So the curve crosses the y-axis at 0, minus 6. Also, we have that as x tends to infinity, y also tends to infinity, and as x tends to minus infinity, y tends to minus infinity too. And therefore our curve will look something like this. The key points have all been indicated on this graph. Now let's have a go at another exercise. Given that x plus 2 is a factor of 4x cubed plus 5x squared plus a, find the value of a. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. Let f of x equal this polynomial. Then substitute x equals minus 2 in f of x. We do this because x plus 2 is a factor of the polynomial. And therefore, we have that f of minus 2 equals 4 times minus 2 cubed plus 5 times minus 2 squared plus a is equal to 0, since x plus 2 is a factor. Rearranging and tidying up gives us minus 32 plus 20 plus a equals 0. Which gives us a equals 12. This brings us to the end of this session. If you have understood its contents, you should be able to state the factor theorem and apply it to various applications. Thank you very much for listening.